Hey you guys, we are in Chapter 5 and we're going to look over the first part of Section 5. We're looking at theorems about roots of polynomial equations. So the first theorem we're going to look at is the rational root theorem. We're going to use this theorem to find possible rational roots, and then after we figure out the possible rational roots, we'll determine which ones are actually rational roots. So we're going to look at these first two objectives. So one way to find a root of a polynomial equation is to just guess and then check using synthetic division. We'll know that it's a root using synthetic division if our remainder is 0. However, this is pretty inefficient unless there is a way to minimize the number of guesses or possible roots. Our rational root theorem does just that. It narrows down the choices of possible zeros or roots. We know our zeros and roots must be of the form P over Q, where P stands for factors of the constant term and Q stands for factors of the lead coefficient. So our first step is to find all factors of the lead coefficient and the constant term. And our step 2 is to divide the factors of the constant term by the factors of the lead coefficient. Alright, so let's look at this example below. It says, what are the rational roots of x cubed minus x squared plus 2x plus 5 equals 0? So when we have a question like this, you first want to determine the factors of the constant and the factors of the lead coefficient. So our constant here is 5. So factors of 5, we know 1 times 5 gives us 5. We also know negative 1 times 5 gives us 5. So we could say plus or minus 1 and plus or minus 5 are factors of 5. Factors of our lead coefficient. Our lead coefficient in this case is 1. We know 1 times 1 gives us 1, and we know negative 1 times negative 1 gives us 1. So our factors of our lead coefficient are plus or minus 1. Now again, to find the possible roots, we just take each p, factors of our constant, and divide it by each q, factors of our lead coefficient. So 1 divided by 1, taking my first factor of my constant and dividing it by my factor of my lead coefficient, I just get 1, so plus or minus 1. And taking my other factor, 5, dividing it by my lead coefficient, I get 5. So this problem, not too many answers here. We only have 4 possible roots. My 4 possible roots are either 1, negative 1, 5, or negative 5. Alright, so now let's use that rational root theorem to actually find a rational root. So our first step is to use synthetic division to check our first option for our polynomial. Step 2 will continue until our polynomial is equal to 0 for one of the possible roots. Alright, so for example, it says, what is a rational root of? And here's our example. So our first couple steps are to find factors of our constant and factors of our lead coefficient. So factors of our constant is 2. So we know 1 times 2 gives us 2, and negative 1 times negative 2. So plus or minus 1 and plus or minus 2. Our lead coefficient is 15, so we have a lot here. We know 1 times 15, we know 3 times 5, and then they're negatives also. So then negative 1 times negative 15, or negative 3 times negative 5. So you should see the routine where all of them are going to be plus or minus. The possible rational roots are, well, we just take each p and divide it by each q. So taking the first one, I'm going to divide it by each, and I will get plus or minus 1, plus or minus 1/3, plus or minus 1/5, plus or minus 1/15. And taking the second factor and dividing it by each, I get plus or minus 2, plus or minus 2/3, plus or minus 2/5, and plus or minus 2/15. Alright, so now I want to use synthetic division to check each of these possible roots to see which one is a factor. And I'll know it's a factor if my remainder is 0. Alright, so the roots I would first check using synthetic division are the whole number roots. So I would try 1, -1, 2, -2. So that's exactly what I'm going to show here. So trying 1, I have to write out my coefficients for my polynomial. So 15, -32, 3, and 2. So the first one drops 15. Multiply it by 1, I get 15. Add those together, I get -17. Multiply by 1, -17. Add 3, -14. Multiply, -14, and I get -12. So this one did not work. So 1 is no good. I'll try -1. Write down my coefficients, 15, -32, 3, and 2. Bring down my 15, -15, -47, +47, 50, and -50. So then I get -48. This one also does not work. I'll try 2. Bring down my coefficients, 15, -32, 3, and 2. I'll drop the 15, I multiply to get 30, add, I get -2, multiply, I get -4, add, I get -1, multiply, I get -2, and I get 0. So yay, 2 is a factor. Once you find one factor, remember if we plug in the x's here, this would be 15x squared minus 2x minus 1. I know that 2 is a root, so I'm going to put that down here. But I know that there should be 3 roots since this is a cubic. So in this case, I'm going to see if I can't factor this. What multiplies to be -15 but adds to be -2? And I know that's -5 and 3. So then I could break this apart to 15x squared minus 5x plus 3x minus 1. And I can group. And I get 5x. Left over is 3x minus 1. And the GCF here is plus 1 with 3x minus 1 left. So then I group the 5x plus 1 and the 3x minus 1. And I see that my other factors, if I set these equal to 0 and I solve, my other factors are going to be -1/5 and a +1/3. I'm sorry, my other roots. So these 3 are my roots to my polynomial. Alright, it's your turn. I want you to list all the possible rational roots for these 2 problems and then find any actual rational roots. I'll give you a hint. Number 1, it does have 3, but number 2 only has 1 rational root. So after you find 1, you're done with number 2, but for number 1 you have to find all 3. Alright, you guys, I will see you in class tomorrow. Thanks.